So without further ado, I'm going to hand over to Kaarin Goodburn from the Chilled Foods Association. Thank you, Kaarin.
Hi, thank you everyone for the invitation to speak to you today. It's what's a really important event for South African food industry and for a lot of people around the world as well. I'm going to just cover in my presentation what is chilled food, because we focus on chilled prepared foods need to be kept in the fridge. Why is Listeria Monocytogenes important? I think everybody in the room will recognise why it's important at this stage. High risk foods, what they are, and vulnerable groups, what they are, and why the two should not really meet under normal circumstances. Controls that should be in place, and then the prevalence of Listeria monocytogenes, which I'll call LM from time to time. The prevalence in different foods around UK, European Union, and a bit broader, and what does good look like in terms of control of Listeria mono. And also I'll end up with a slide with guidance that's available from us, some of it free, some of it already provided through Food Focus, for example, to industry as a service. But there's plenty of information out there, so don't feel lost. Okay, so chilled food is for us a food that needs to be kept at refrigeration temperatures, and in England, Wales and Northern Ireland that's at or below 8 degrees, which is very high temperature, throughout its entire life. Now, we actually operate at 5 degrees as an industry in the UK, and that's the target delivery temperature into supermarkets. And the guidance for consumers is to keep your fridge no more than 5 degrees C. And we supply fridge thermometers, and it's really important that food is refrigerated properly, and I'll show you why. There are 3 categories of chilled food. We have ready to eat, which is the one that's associated with listeriosis. Ready to reheat, so that's ready meals which have already been cooked but they're going to be warmed up, and they're ready to cook, so it's going to have a full cook process. 70 degrees for 2 minutes is what we call a cook process. 3 categories of food, everything falls into one or the other. A bit about us. So the association has been in existence since 1989 and was formed to establish best practice standards, self-regulation standards for the UK chilled sector on the back of a listeriosis outbreak that was caused in the UK by imported Belgian pate. So we had a listeriosis outbreak 30 or so years ago. It was 1988. And from that, we established the standards, and we protect the industry by protecting the consumers. There is no industry unless you protect your consumers. Our membership is limited to chilled food manufacturers. They have to have BORC or IFS certification. We want to see their non-compliances list and how they close them out. We want the CV of the person responsible for food safety in the business, and we want a reference from an existing member, because our membership is built on our standards and compliance. That's the only way you can actually encourage and nurture consumer confidence. So I've mentioned 3 key terms. So ready to eat is actually defined in European law, and it uses the definition that we proposed. This is food that is intended by the producer or the manufacturer for direct human consumption without cooking or other processing that's going to reduce or eliminate microorganisms of concern. So we call that cold eating. So you'd be cold cuts of meat, for example, that you might have in a sandwich or in a salad. So that's clearly ready to eat. And sushi would be ready to eat as well. This is made in a high care or a high risk area. We have the ready to reheat category, which is designed to be reheated by the consumer, like a ready meal that's already been cooked. And that's also made in a high care or high risk area, but not at the same time as a ready to eat food. So these are segregated. Ready to cook is going to have 70 for 2 process throughout all the components, and that's made in a low risk or GMP area, as we call it. Now, the key pathogens to be considered in chill, clearly, Listeria monocytogenes, it's vegetative, it doesn't form spores, it just grows. Spore formers, we can see on the right, there's Clostridium botulinum spore here. So these organisms, such as Clostridium botulinum and Bacillus cereus, they form spores which are very stable for a long time and can normally withstand quite a lot of heat. Thankfully, Listeria mono does not do that, but it is quite thermally robust. It's quite heat resistant. bit about listeriosis. There are two different forms of listeriosis. The invasive one, which is the one you appear to be having at the moment, is similar to meningitis, causes blood infections, septicemia, spontaneous abortion, stillbirth, and then local infections like skin infections. So here is a baby with listeriosis, and you can see a bit of a rash on its arm. I don't know whether the baby lived or died, but to be born with listeriosis is almost the worst way to enter this world. And that would have come through the mother's placenta, transmitted from mother to child. Non-invasive, if you're otherwise healthy, not in the vulnerable group, not pregnant, for example, then you might just have a mild feverish sort of gastro symptoms. Unfortunately, in England and Wales at least, most of the listeriosis over this period of 2008 to 13 was the bacteremia. So 80% of it was actually the most serious sort. And in the middle of the brain scan, just off to the right, you can see a white edge patch. That is septic brain. So this is extremely serious. It crosses the meninges, crosses blood-brain barrier, crosses placental barrier. This is not your ordinary diarrhea and vomiting organism. This is an absolute killer. Vulnerable groups should avoid high-risk foods, or at least treat them with care. And those vulnerable groups are people with weakened immune systems, and they're very susceptible to all sorts of infections, but including listeriosis. And if they get it, they're more likely to suffer the severe symptoms, the invasive. And you can see here a list of all the sorts of people who will be in the vulnerable group. And you have to consider together, when you take all of these different categories of people, is that really the majority of the population that's in the vulnerable group? Really, is it? We can see all sorts of things. And people with immunosuppressive or cytotoxic treatment, when you think of HIV, that certainly would be putting you in the vulnerable group, for example. And the big one, of course, here is pregnant women too. The foods of risk to vulnerable groups, these high-risk foods, this is identified and very clearly understood in Europe and the USA, and most countries that recognize it is ready-to-eat food that has a reasonably long shelf life and is quite high in protein normally, because Listeria likes free amino acids. So we're talking about fish, meat, pasteurized and unpasteurized cheeses, and foods that contain them. So sandwiches, for example, or salads. And then some cut fruits like melons, they can be contaminated, but really that was quite extraordinary. If you roll a fruit across the dirty floor with Listeria on it, then cut the fruit, so the Listeria will go inside the fruit. But the big ones are fish, meat, and then dairy products, these cheese products. Now, when you look at fatal listeriosis outbreaks, we go back to Canada 1981 with the first proper documented one. There it was actually coleslaw, and it was contamination of the cabbage in the field by sheep grazing. So it was sheep poo, because this is an environmental pathogen. It's out there in the environment, it's in the soil, it can come from animals as well. That outbreak in Canada killed 18, and there were about 41 cases from coleslaw. And then we looked through these different cases going through the years. 1985, 48 dead, 142 from fresh raw milk cheese, Mexican style, queso fresco. This was our outbreak in the UK, 1987 to 9, which was the imported pate. That's high protein. I understand that was temperature abused on the way to the UK. So Listeria grew quickly. In France, we got another meat type product with 92 dead and nearly 300 ill. Italy, a non-fatal outbreak, but a lot of people made ill by the more febrile sort of gastroenteritis type of symptoms. So that it wasn't fatal, but I put it in here because a lot of people were affected. And you can see we go down, we've got contaminated meat, sandwiches, which would be protein filling, sliced meat, chicken wrap. These were the cantaloupes that are on dirty premises. Sandwiches would be the filling there, not the bread. Could be the butter, but it's mainly the filling. Denmark, 17 dead from cooked meat. Determined, that was identified through whole genome sequencing, finding samples of food that match with people's samples. And the same in the USA with ice cream. So even frozen food that's ready to eat is high-risk food. And some more recent ones, Canada and USA, are leafy salads, and that seems to be indicated by poor hygiene at the processing plants. And then, unfortunately, you have your outbreak at the moment. These outbreaks all relate to ready-to-eat food. You have to look at what people are eating. It's the ready-to-eat food that's a big one. It's not going to be a raw meat because people cook it. And if some people cook it, they will be destroying Listeria, but most people cook raw meat anyway. So we're talking about ready-to-eat food as a high-risk group to look at. We look at listeriosis rates in the UK and Europe generally, and we can see from the number of confirmed human cases, which is the second column, that although there are more cases of Campylobacter than Listeria, it's 100,000 times, 100 times more cases of Campy. It kills very few people. When you look at the reported deaths on the third column from the right, you see 247 people died in 2016 across Europe from listeriosis. And that is more than the rest of the top four organisms which are listed above. So it kills probably 15 to 30% of people depending on who becomes infected. And that was the case fatality rate in Europe for the last set of data, which are these. And you can see, comparing the case fatality rates, that Listeria is a hell of a lot more dangerous than the other organisms in terms of deaths. So in 2016, 540 times more lethal than Campylobacter, and 147 times more lethal than Yersiniosis, and 60 times more lethal than STEC. So this is a very dangerous organism and it has to be controlled. When you look around Europe, the case rates are per 100,000 people going back 3 years, and compare it with USA, Australia and New Zealand and your current outbreak rate, you can see that the countries listed here in red have higher than the European average, higher than the European mean number of cases. We are thankfully below the mean, have been for many years, because of the investment in the industry in putting the controls in place. And we have an integrated supply chain with Ireland, and they have similar standards. But other countries are eating a lot of fish, for example, or a lot of cold meat products. Or in Spain, they're having a lot of tapas, so they have a high rate, which is my theory there. So if you're eating ready-to-eat protein-based foods, that's really is the highest risk. And if people who are in vulnerable groups are eating them, that's the worst combination possible. So the USA rate is about the same as the Australian rate, which is about the same as the UK rate. New Zealand rate of listeriosis is double us and Australia and USA. And your outbreak rate works out at about 1.5 cases per 100,000, which is higher than anything we've seen in any European country since there was a massive outbreak in Denmark in 2014, which was related to ready-to-eat meat products. So you have a very serious issue, as you understand. When we look at chilled prepared foods, we can see ready-to-eat variants are highlighted in green here, and we have specific rules for these in European law. Entrees in English, not American English, means a starter, like it does in French. So some of those are ready to eat, and you go all the way through dressed salads, leafy salads, prep fruit, deli products like the meats and the fishes, ready to eat fish products as well, dips and dressings, all sorts of things ready to eat. So those are treated with the highest care. So what makes a food ready to eat? A lot of time and attention and investment makes a safe ready to eat food. Starting with the HACCP plan and the design of the product, making sure if you're using any raw components like salad, that they are grown to good agricultural practice standards, so they're not going to be contaminated by organisms such as Listeria and others such as STEC and Salmonella. We want hygienic preparation and packing. We want to prevent re- and cross-contamination. Hopefully there's a process that kills the target organism. Normally that's heat. We want limited shelf life, so it's highest quality, and there's as little time as possible for microbial growth. You give an organism time to grow and otherwise good conditions, and it will do so. Shelf life can limit that time. We chill from the point of manufacture just to keep the growth rate down. And we give appropriate usage instructions, which is chilled storage, the time you can store it, the durability date, are you going to eat it out the pack, reheat it or cook it? So all of that needs to be considered on a food product. We can represent it by this. From the raw materials on the left have to be good quality and kept chilled. Manufacture, well, we've got to have area segregation. We want thermal processing wherever appropriate to reduce contamination. And we want rapid post-process chilling. And then afterwards we want chilled distribution, limited shelf life and good usage instructions. All of that has to be in place for it to work. A bit about Listeria, which you've heard about. I'll just say it's extremely tough. It's found all over the place. It's found in the soil, in water, in animal feces, in vegetation, and 10% of us have it without any symptoms. We say in the UK it can take up to 3 months before symptoms disappear, so it can be difficult to track the source, as you're unfortunately finding out. It grows at fridge temperatures when Salmonella and E. coli don't. It survives freezing, so it has to be considered in frozen food as an organism, particularly ready to eat. It doesn't mind a bit of heat. It really doesn't mind if there's vacuum present or not, so vacuum packing doesn't do anything to really control it. It can survive in 20% salt solution and it's quite acidic solutions as well. pH for growth is about 4.2. And then the big thing is it forms biofilms on surfaces. And I've already said about vulnerable groups, but it's the main cause of death from foodborne illness in the UK and EU. And these are highly sophisticated industrialized countries. The big thing you need to remember is that the major transmission through is into humans is through contaminated foodstuffs, and specifically ready-to-eat foodstuffs are the major link. I've put here on this table some parameters so you can refer to those if you're formulating products. It talks about growth and survival. I would just say that on the survival side, you can see it survives -18 Celsius. So having high levels present in a ready-to-eat frozen food is just as bad as having high levels growing in a ready-to-eat chilled food. You just don't want significant quantities of this organism in the food. We have legislation in the EU which says 100 per gram, and you have to comply with hygiene to achieve that time after time. So the basic food safety rules, as you know, clean, cook, avoid cross-contamination, and keep it cold. So these are the 4 C's. And there's actually a 5th rule, which is use good quality raw materials or other ingredients, particularly if they're going to be eaten raw. So I'm just going to work through these backwards. So the raw materials, we've set out good agricultural practice standards that apply to the salad industry. It means having agronomists on site, making sure the site has been selected properly. There were no previous use with grazing animals. That means there's contamination, for example, or make sure the water is not contaminated from various sources that you're using to irrigate. We want no human-derived waste on ready-to-eat crops at all. Animal-derived waste such as farmyard manures are not used on UK retail prepared ready-to-eat food. Okay, they're just not used unless they're composted for a long time and there's a big interval. I mentioned irrigation water quality, renowned for contaminating salad crops in particular. Don't let animals access, even dogs and cats. Birds should be scared away as well. And we need to make sure that human hygiene is maintained, so there have to be toilets and hand washing facilities in harvesting areas, which is what the picture on the right is. We have grower and processor contracts and audits to back up all the systems that we put in place. And that's what needs to happen on raw ready to eat. Bit about the ecology. So you've got yourself a clean factory, and Listeria comes in on staff because we carry it, we bring it from the environment, and on the raw materials that you're putting into the factory. The big thing here is that if you can't find it, you're not looking hard enough, and you need to start looking in the drains. The drains would be the hot spot unless you take really special measures, unless you're putting a lot of sanitizer down there, unless perhaps you've got copper lined drains or some really fancy investment going on. If you let Listeria survive hygiene, it will spread throughout an environment. It will create aerosols and persist in the environment, and then it will get onto the food stuff and cause people to become ill or die. The big thing with Listeria is that it forms biofilms, and I put a little diagram at the bottom saying you can get bacteria sticking to a surface within seconds, and it becomes permanent within minutes, and they start to grow, and they produce their own gunge, a sort of polysaccharide and protein glue, and it becomes a very mixed, vibrant colony of all sorts of things you do not want in your factory. The way to avoid it is to have good hygiene systems. That means cleaning, physical cleaning, getting rid of the protein first, and then disinfecting. And I've put a link here to some guidance which I've already provided to Food Focus. It's freely downloadable. How to clean and disinfect in very top level terms, and it includes cleaning schedule examples and what certain chemicals are suitable for, what surface materials, for example. So again, on cleaning, the hot spots, well, Listeria likes cold and wet. So if you have warm and dry, that's not bad for Listeria. It would compromise its ability to grow. And we have some examples here, real examples. If you see some rust from some joined surface, you can be sure that something is leaking somewhere. And on this right-hand picture, this stopper was taken off the big vessel and was found to contain Listeria underneath it. It just gets inside, and as long as it's left quiet and cold and wet, it will grow. And it particularly likes drains, as I said, because all of the nutrients that you wash down off your surfaces end up in the drains, and they're difficult to clean. You must never use a hose down a drain when food is around, and it needs to be left to settle for several hours afterwards because it forms an aerosol. You can find it in the perished rubber seals of doors, and there, when the door opens and closes, it just lets out a little aerosol of Listeria into the environment. And then the classic one about bad joins as well, but drains is the big one. If it's not in your drains, you stand a chance, but you can't forget all the other areas too. So a drain is a non-food contact surface. This table is in the cleaning disinfection guidance I mentioned. It shows that you must clean the protein residues off first. So this is cleaning followed by disinfection, at least a two-step process. And we can see these different sorts of sanitizers here have different level of efficacy on inoculated Listeria on these surfaces. And we can see the quaternary ammonium compounds are really highly effective, giving a 6 log reduction, so a millionfold reduction. If you don't clean the protein off, you reduce the efficacy by a factor of 10 for quats, and it can be higher for different, like hypochlorite. It comes down from 5.5 log reduction to 2.8, which is a 100-fold reduction on efficacy, more than 100-fold. Clean the protein off first, physical cleaning with detergent, and then we have disinfection. Just a picture about, do not use high pressure hoses. Just don't use them, because they just put all the Listeria in the air. As you can see in these pictures, this is just an aerosol of organisms and vapor. Don't use high pressure hoses because they generate aerosols. It takes hours for it to come down, if at all, by which time it's contaminated the whole of your factory. Low pressure hoses only, and not during food production. So we've got some hygiene areas here. We can see a chicken here. We want separate equipment, staff, utensils, changing areas. This is how it's built in the UK. So we have a separate area where raw ingredients and packed final products are held. So it's two ends with a middle area where production is done. Raw materials coming in, process, which may just be, in the case of a chicken here, the slaughter through to the final pack. And these are ready to cook foods. These are low risk area. This is not linked with Listeria cases historically anywhere. High care areas, ready to eat or reheat foods. High care is where it's got a raw component in. So a salad, this cheesecake has a bit of strawberry that's raw on it. Sandwiches have raw veg, and of course sushi has some raw veg, and there's some raw fish as well. So that's a high care area, ready to eat or reheat. It's got a raw component. So you can only minimize contamination because the raw element has not had a good reduction, a 6 log reduction. High risk area is for foods ready to eat or reheat, but everything has been through a 6-log process, we call it. So it's had at least 70 degrees for 2 minutes. And here the air is filtered as well, and separate staff, utensils, everything. And the aim there is to prevent contamination, because the area begins from the emptying of the cookers into the high-risk area where the food is then built into, for example, lasagna. So only fully cooked food goes in the high-risk area. This is a little table showing you how the high-risk area system works for us: ready to eat, ready to reheat, and ready to cook. So I'll just give that to you for reference. Looking at the 4 C's still, we've done cleaning, let's do a bit of cold. So this is European micro regs, which say you've got to do shelf life studies. You can't just put the use by date or whatever date you fancy without any science. You give a food a longer time to be stored, means it's got more opportunity for abuse and more opportunity for any organisms to grow. And the European regs say you must take into account the storage and processing conditions. So that means the expected storage temperature, not what you'd like it to be, but you have to have some knowledge about how your chill chain actually performs. You can find all sorts of different lengths of shelf life for the same sort of product around the world, and I've got some examples here. You can see that sandwiches you'd think are fairly similar. We work about 2 days shelf life in the UK for major retailers. Other EU, you can have some quite low water activity, quite dry fillings that give you up to 2 weeks. And the sandwiches on the right I met in the USA, and they have a very long ingredients list with all sorts of chemical preservatives in there, which we don't find acceptable in the UK market. You can see it's cold smoked salmon. In the UK, we have about 3 weeks shelf life, but it's 4 months in the EU and USA. And you have to say, why are these shelf lives different? And the answer is either preservatives are being used, or people are just saying, I'm storing it at 2 degrees or 3 degrees or some other temperature that can't be reached in reality in the chill chain or at home. Or they're not validating the shelf life at all, or they're just doing what the customer asked. And none of those are valid unless they've been through a scientific evaluation. So bear in mind your shelf life is extremely important, and it has to have a scientific basis, at least in EU law. You can see why shelf life is important here. I've just done some modelling, predictive modelling on Combase, which is a combined database, UK, USA, and I think Australia as well. And you can see here from the 2 graphs, the orangey curve shows Listeria growth rate at 8 degrees versus, on the purple, the 5 degrees. And it grows about twice as fast at 8 degrees than it does at 5. And if I was to draw a graph and say, how fast does it grow under neutral pH and not a lot of salt, then you'll see at 10 degrees, it grows 3 times as fast as 5. This is why refrigeration is extremely important to suppress the growth rate of Listeria Monocytogenes. So how cold are the fridges at home? This is some data that's international, and it was gathered it about 10 years ago and put it in a report for the UK government. And we can see that about 40% of fridges were up to 5 degrees. That means 60% were above 5 degrees, which is the recommended temperature. And we can see also that 20% or so were above 80 degrees. So that how bad the fridges perform at home is a high determinant of how ill people can become. If it's a higher temperature at home and there's a long shelf life, then there's going to be more opportunity and possibility for Listeria to grow. So you have to understand how your chill chain for distribution and the consumers works. So what does a good level of control look like? So we've got clean, we've got good quality raw materials, we're avoiding cross-contamination by having separate hygiene areas with separate equipment and staff. We've got thermal process as well in place. So what does a good level of control look like? Well, you only know if you do sampling. So for ready-to-eat foods in particular, carry out regular environmental swabbing and then food sampling, and this is required by European law. So Environmental sampling, you need to go for those drains, go for food contact surfaces, places that are difficult to clean, places that are cold and wet, that don't really get disturbed, and try and find Listeria monocytogenes, and then attack it with hygiene. Really attack it and dismantle equipment down to nothing if necessary. The results of the environmental swabbing need to be trended according to European law, and if there's a trend upwards, it needs to be addressed through hygiene measures being implemented. That is perhaps deep cleaning, or other measures like periodic dismantling, as I said, or on a specified frequency. Environmental swabbing is important because it validates the cleaning method that you're using. So if the results come back negative, and you can use ATP as a quick thing, then it means your cleaning process, as long as you swab the difficult to clean places, it means that that's going to be effective. It also should be done all the time to verify ongoing efficacy of cleaning. So after each clean, there should be swabbing, ATP or proper micro tests. Food sampling also needs to be done. What we do with CFA is, on the day of production, samples can be taken, and that's a good indicator of the hygiene of the plant and the production area and the course of the food, and at the end of life. So we want to see no exceedance of any legal limit at the end of life, preferably no Listeria whatsoever. And at the end of life, the data tell you how appropriate the shelf life was. So it tells you about hygiene and the shelf life, which are both really important. Some prevalence in ready-to-eat foods. There's some quite oldish and newer UK government survey data here. This is cooked sliced meat, ready-to-eat food, high protein. Slicing is a great way of contaminating things as well, so look at all your slices. So we can see cooked sliced meat goes about 1.5 to 3.8% prevalence, so that's presence of Listeria. And sandwich bars didn't come out so well, with 5.7% in this survey over 10 years ago. When you look at European data, there's about 13,000 samples were brought together in 2010 to 11, and it found some really high prevalence on the fish, meat and cheese. We're sampling these because these are ready to eat high risk foods, which is where the focus should be. So we see some really high prevalence of over 10% on the fish, and even more than 1% with more than the legal limits, which I find astonishing because we don't see those figures in CFA members. So what does good look like? The figures that I'm handling, and we have 1 million data points for environment and about the same for food as well, going back over a decade. We gather it all the time from members. We're looking at a prevalence of Listeria mono in food of less than 1%. And the vast majority of those 1% of samples are not countable. So it's detected, but it's not enough to count. We don't have 100 per gram occurring every day. We've had it perhaps fingers of one hand in the last 5 years. We've found that many exceedances of 100 per gram because we put the effort into the hygiene and control in the system. On the production environment, it's different on food contact and non-food contact. I said drains are a big issue. Non-food contact, such as drains, good is less than 3% positives for Listeria mono in your swabs, and food contact less than 1%. So you see, for us, to find Listeria, you need to take at least 100 samples to actually stand a chance of finding that 1% in the case of food contact or food itself. Or perhaps 30 samples, you might find some. So if you're taking a few samples and they're all positive, or the majority are, that's really extremely bad news. We're looking for this sort of level of performance for a system that's under control. So how do you get there? We've got all sorts of guidance. The main one is the best practice production guidelines. That's available from the first link. The cleaning and disinfection using biocides is a free download. The shelf life guidance is a download that's free as well. And other guidance is available through our website, and you can see the documents here. The Listeria management guidance, which is the fourth on the list, I've given Food Focus a copy of the first edition, which we're gradually updating. So they have that, and that's to try and help you out. That tells you where to look for it and what to do when you find it. So the ethos is look for the Listeria and deal with it. and don't get it going into the food and causing problems. So I'll end there, and I hope you found that useful. Always happy to deal with questions, and I really wish you well to get on top of this situation, this terrible situation.